Hello and welcome to the ISO 14046 Water Footprint Calculation and Water Management course. Today we set out on an educational journey to explore the ISO 14046, a key standard for the quantification and responsible management of water resources. Our goal is to understand how to measure and mitigate water impact in production and services, which is crucial in addressing water scarcity and pollution. Water's importance for life and sustainable development cannot be overstated. It's a critical resource in industry, agriculture, and our daily lives. Facing growing pressures on our water resources, it's essential to adopt practices that safeguard their future availability. This course and workshop is designed to argue with the knowledge needed to implement water management strategies based in ISO 14046, encouraging efficient and sustainable water use in your areas of work. We will explore fundamental concepts such as water balance and the different types of water footprints, for example, gray, blue, and green. And we look at case studies and practical application, not only understand the theory of water footprint, but also to apply this knowledge to effective decision making and integrated water management in our organization or projects. Okay? But before we dive in, let me introduce myself. I am Diego Fernando Roman. I am an electrical engineer, occupational health specialist, MBA, and experienced auditor in management systems. My expertise lies in energy efficiency, sustainability, and management systems. With over 50 years of experience, I have assisted organizations across all Latin to optimize energy usage, enhance efficiency, and align with international standards like ISO 50001 and ISO 14001 and ISO 14067 related to footprints management. Okay, as a qualified auditor for ISO 9001, ISO 45001, ISO 50001, ISO 14001, and ISO 14067, I have conducted over 1,600 audits globally, aiding organizations in enhancing their energy and environmental management system and reducing their carbon footprints. Okay? Also, education and training are key elements of my work. Through 880 grados consultores and the Academy 180, I have developed and developed courses on ISO standard focusing on energy efficiency, environmental management, and carbon footprint, teaching over 1,000 students worldwide on platforms like Udemy and Hotmart, where I achieved a high satisfaction rating, 4.4 over 5. Okay? So I'm excited to share my expertise with you in this workshop and course, particularly focusing in the water footprint. Okay? So without further ado, let's get started. Okay, let's start to explore the benefits and scope of the ISO 14046 standard that is an essential tool in sustainable water management. Okay, this international standard is pivotal in providing transparency and consistency in assessing and reporting the water footprints of products, processes, and organizations. Okay, what sets it apart is its foundation in life cycle analysis in accordance with ISO 14044. Very important, this standard, allowing for a modular approach and a deep understanding of water-related environmental impacts. ISO 14046 not only addresses water consumption quantity, but also changes in water quality. Very important, the water quality in this standard, integrating hydrology insights. This is crucial for evaluating the magnitude of potential environmental impacts and for identifying opportunities to reduce these impacts at different life cycle stage of a product. Okay. Moreover, this standard is an ally in strategic water risk management, facilitating water efficiency and optimization at the product's processes and organizational levels. It serves as an invaluable guide for decision makers, offering scientifically evidenced information, very important, the scientifically evident information for more effective and sustainable water management. Okay, now the ISO 14046 standard sets out a clear framework for assessing the water footprint, focusing on product, processes, and organization. Okay. Also, in this standard, products and services is the same. Very important to understand this, and that apply to all organizations. Okay. The scope of this standard is for all organizations. So this framework is grounded in life cycle analysis, or LCA, ensuring a comprehensive and systematic evaluation of water impacts. This standard goes beyond just the direct water consumption. It also considers how air emission and soil discharges affect water quality. Very important this, okay? It's not only the water consumption, also affect the water quality is an aspect important to manage in this standard. This holistic approach ensures all relevant aspects of water impacts are considered. The outcomes of this evaluation can be presented in two ways: as a singular value or as a detailed profile of impacts, thus providing a clear and complete understanding of the water footprint. Okay? An important point to highlight is that while ISO 14046 covers the detailed assessment of the water footprint, it does not include the communication of the results, such as labels or, for example, declaration. For this purpose, we recommend you the ISO 14026, and that provides specific guidelines for the communication of environmental information. Okay? In this way, the ISO 14046 becomes as an essential tool for those seeking to assess and understand the water impact of their activities. Okay? Okay. Now, in implementing the ISO 14046 standard, it's crucial to identify related standards that enhance its application. The directly linked standard is ISO 14044, okay, which focuses on life cycle analysis and is an essential requirement for water footprint assessment. However, additionally, for a more comprehensive approach to environmental management, we recommend you considering optional standards like ISO 14004, which provides guidelines and support the environmental management system. Okay. Also, the ISO 14031 plays a significant role, offering guidelines for measuring and evaluating environmental performance. Okay, like gaps. That is very important to complementing the assessment conducted under ISO 14046. Okay. Another one, a critical aspect, is the communication of water footprint results. So here the ISO 14026 is the go-to standard, offering a framework for effectively communicating environmental declaration, including the water footprints. Okay? So very important, in summary, includes additional standards for your knowledge, for your framework, and more comprehensive environmental management and communication. Okay, in our study of ISO 14046 standard, it's essential to understand the key terms, the definition that is in the chapter 3 of the standard. And it's very important to start before the concept and definition before to start to make the water footprint reports. Now we're gonna start with the concept of fresh water. According to the standard, fresh water is defined as a water with a low concentration of dissolved solids. This is crucial for distinguishing between different types of water resources in terms of quality and potential use. There are two notes, very important notes, to understand the condition of fresh water. The first note to this definition clarifies that the fresh water commonly contains less than 1000 milligrams per liter of dissolved solids. Okay, very important to understand this. Among these dissolved solids, we typically find minerals like salts, like calcium, magnesium, sodium, and potassium, as well as bicarbonates, chlorides, and sulfates. Okay, these components are essential for determining water quality and its suitability for various uses, including human consumption. Moreover, the standard notes that the concentration of total dissolved solids can vary significantly in different places and time. This is in the note 2. This implies that water quality is not static and can be influenced by environmental or human factors such as agricultural runoff, introducing nitrates, or industrial pollution contributing heavy metal, for example. Okay, so it's very important to understand this definition because we're gonna use a lot of times the fresh water in the water footprint. Okay, continuing our exploration of ISO 14046 standard, understanding the concept of brackish water is important. The brackish water is defined as a water containing more dissolved solids than fresh water but less than seawater. Okay, this makes brackish water an unique category in terms of quality and potential use. Also, there are two notes in this concept, and the first note clarifies that the concentration of dissolved solid is in the brackish water can range from 1000 to 30,000 milligrams per liter. This is significant as it indicates that brackish water can vary from being slightly saltier than fresh water to almost as salty as the seawater, affecting its suitability for various uses such as irrigation in the agriculture or human consumption. Furthermore, the second notes indicate that the concentration of the total dissolved solids in many brackish water can vary considerably, both spatially and temporally. Okay, this suggests that the quality of this water is subject to change due to natural and human factors, which can have important implications for the sustainable management of water resources. Okay, so let's continue with another concept of water types, and it's crucial to differentiate between various water categories. We start with the surface water, defined as the water that flows and is stored on the Earth's surface, such as rivers and lakes. This category explicitly excludes seawater and is vital for water footprint assessment, especially in regions where rivers and lakes are primary water sources. The standard also defines the seawater. Okay, the seawater is the water found in the sea and the ocean. Okay, his principal feature is its highest concentration of dissolved solids, generally more than 30,000 milligrams per liter, significantly differentiating it from the fresh water and brackish water. Okay, another one is the groundwater. It's another important category referred as the water contained in the subterranean formation that can be recovered. This water source plays a vital role in many regions, especially for water supply and irrigation. And lastly, the standard mentions the fossil water, a subcategory of groundwater, characterized but an insignificant rate of natural resources on the human timescale, often described as a non-renewable. This category is critical in assessing the sustainability of water resources, as its use implies the restriction of water reserves that do not replenish at a sustainable rate. Okay? Very important concepts. Okay. In applying the ISO 14046 standard, it's crucial to understand key hydrological concepts, starting with water body. This term refers to entities of water with a specific characteristic in a designated geographical area, such as lakes, rivers, seas, and glaciers. Detailed georeferencing of these water bodies is essential for accurate water footprint assessment. Okay? Another important concept is the watershed, which encompasses the area where water runoff from precipitation drains into a stream or water body. Okay? And it's very different, the watershed with the water body. Okay? It's important to distinguish between surfaces and groundwater bases, and they don't always overlap. Moreover, a detailed and georeferences understanding of this watershed is vital for identifying how water moves and collects in a given area. Finally, we have elemental water flow, very important for our studies. Refers to water entering or exiting the system under study. This flow can include water extracted from or released into the environment and is a critical component in understanding the water balance in the context of the water footprint. Okay, so 3 very important concepts that you have to understand. Okay, so let's continue with other concepts core of this standard and that is essential to understand definition related to water footprint. And start with the definition water footprint. Water footprint is defined as the metric or metrics used to quantify environmental impacts associated with water. It's important to note that if impacts are not assessed comprehensively, the term should be used with specific qualifiers such as water footprint for scarcity or water footprint for eutrophication to clearly indicate the category of impacts assessed. Okay, very important to understand this. Another concept is the water footprint assessment. Involves the collection and analysis of the inputs, outputs, and environmental impacts of water use or affected by a product, processes, or an organization. This assessment, often used synonymously with a study, is crucial for understanding the full scope of water-related impacts. Lastly, the comprehensive water footprint assessment refers to an assessment that complies with the principle of integrity. This means considering all relevant environmental aspects of water, including its availability and degradation. This comprehensive approach is essential for gaining a complete and accurate understanding of water impacts and for making informed and responsible decisions in the water management. Okay, continue with the concepts. We're gonna refer with the life cycle. The life cycle refers to all the stages a product goes through, from raw material extraction like mining or farming to the final disposal like recycling or landfilling. Think of this as tracking a product journey from cradle to grave. Okay. The next concept is life cycle assessment or LCA. This is the method to evaluate all the environmental impacts of a product or service throughout its entire life cycle. For example, the LCA would look at how much water is used in producing a cotton t-shirt from growing the cotton to manufacturing the shirt. Okay, this is the magic of the LCA. Then we have the life cycle inventory analysis or LCI.
This is a part of LCA that involves collecting and quantifying all the inputs and outputs in a product's life cycle, and it's like making a detailed list of everything is used and produced in the making that t-shirt, including water and energy. Okay, specifically the water footprint, there is the water footprint inventory analysis. This phase focuses on gathering and quantifying all aspects relating to water for product, services, process, or organization. And it includes not just water usage, but also how emissions from air, soil, and water affect water quality. Okay? So grasping this concept is crucial to applying the ISO 14046 effectively and ISO 14044 of LCA, allowing for a thorough and accurate assessment of a product and service water footprint at every stage of its life. Very important and crucial, these concepts. Okay, now let's continue with other concepts more deeper into the ISO 14046 standard. And we encounter advanced concepts crucial like water footprint profile. The water footprint profile compiles results of environmental impacts related to water. If this profile does not encompass all impacts, it must be accompanied by specific qualifiers to describe what has been assessed. Okay, very important. Another one is the characterization factor. The characterization factor is an element of assessment model that transforms data from the life cycle inventory analysis into common environmental impact indicators. Okay? This allows for grouping and comparing different impacts under a unified indicators. Very important for gaps. The environmental mechanism refers to the rise of physical, chemical, and biological processes that link LCI results with environmental impact indicators. Okay, this mechanism is essential to understand how human activities specifically affect water and ecosystems. Moreover, water availability measures the extent to which humans and ecosystems have access to adequate water resources. This concept relies not only on the quantity of water, but also on its quality and how it is managed. Okay? And finally, the water scarcity addresses the relationship between the water demand and its availability in a specific area. And this concept is vital in our reports for understanding and managing the challenges of water sustainability in different regions. Okay? Very important concepts. Okay, let's continue with understanding key concepts for the ISO 14046, such as functional unit. Functional unit is vital. This term refers to the quantified performance of a product, process, services, or organization used as the reference point. For instance, for a water bottle, the functional unit may be to provide 500 milliliters of drinkable water. In organizational assessments, this term can be replaced with reporting unit. Okay, that is a good example to understand this concept. Now moving on to reference flow, very important concept. This is the measure of outputs from processes in a product system required to fulfill the functional unit. Okay? In our example, the reference flow would include the amount of water used and emission related to produce that bottle. Okay? Very important concept, and we're gonna use in our reports. Another one, the product category groups products capable of fulfilling equivalent function, facilitating the comparison of the environmental impact. And finally, the product category rules, very important concept, refer to specific guidelines for developing type 3 environmental declaration for different product categories. These rules are crucial to ensure that assessments are consistent and comparable. Okay, very important. Understand this concept to accurate and meaningful water footprint assessment. Okay.
Okay, as we conclude this introduction workshop to our ISO 14046 water footprint calculation and water management course, I warmly invite you to embark on the comprehensive journey with us with the complete course. This isn't just a course about the standard. It's a deep exploration in the crucial role of the water management in sustainability. Okay, you will gain deep insights into the ISO 14046 standard, mastering the art of water footprint assessment and management. Okay.
Now, we warmly invite you to join us for the complete course, where each module takes you further into the deep understanding and application of this essential standard. You just see the module 0 with the numerals 1, 2, and 3 of the standard related with the context, object, and scope, and the normative reference. In the module 1 principles, we will lay down the essential groundwork for sustainable water management and water footprint assessment. Okay, very important principles. Moving to the module 2, we're gonna see the methodological framework. Okay, we focus in the life cycle analysis and performance, and we will align our learnings with the protocol of the water footprint network. Okay, the most important and recognized protocol of the world, and delve into detailed inventory analysis. We're gonna make exercises, practical exercises, examples of real organization to your knowledge. Moreover, you will explore the use of the FAO CROWAT 8.0 software, a powerful tool for calculating the green-blue component of the water footprint, particularly in agricultural and forestal contexts. This software aids in understanding and management crop water needs of evapotranspiration, making an invaluable resource for our case study and the exercise that we're gonna explore in our course. Okay, we will be told how to break down the total water footprint into its essential components, identify the amount of rainwater uses, green component, blue water footprint, and also the gray component about pollution water footprint. Okay, so we're gonna make a very practical exercises. Then in the module 3 will be dedicated to the reporting. Okay, focusing on how to prepare and critical analyze water footprint reports. And in the module 4 we will guide you through the detailed and reflective critical review. The last part of the reports related with validation, verification, and audits that is very important for these steps. Finally, in the final module, you not only face an assessment of everything learned, but also be equipped with practical tools, cases studies from real companies, and guidance for apply your knowledge effectively in the field of water footprints. Okay, I'm gonna make an exam to prove your knowledge and for your certificate. Okay, each module is designed to build up upon the last, ensuring that by the end of the course you will have the skills to calculate water footprints, interpret data, and apply this knowledge practically. Okay, very important this.
Also, if you have any question or need further information, please don't hesitate to contact us at the email proyectos180grados@gmail.com. Okay, as you see in the screen. Okay, so click in the purchase course link and let's work together to make a difference in sustainable water management. Okay, see you
in the Module 1. Goodbye.